Hi everyone, my name is Khadija Iddrisu and I'm currently a PhD student at the Dublin City University. So I've also been to the African Institute for Mathematical Sciences to do a master's in maths and a master's in machine intelligence. And now my primary research areas is mainly in computer vision and stuff like that, yeah. And a fun fact about me, I think I like exploring. I like watching movies. I watch movies like every day, like at least 1 hour in a day. And I like listening to music. And the movies I watch is mainly like sci-fi movies. Like those are like my favorite movies. So if you're a fan of sci-fi, let's connect and like discuss after this call. Yeah, so today I'll be taking you through Python numerical computing. And I'm still a learner as well. So pardon me if I make mistakes and like, let's just take the session as like a learning session together. Yeah. So without further ado, I think I would start. So today we'll be looking at numerical computing with NumPy. And NumPy is a library like other libraries with other libraries in Python. So libraries sort of have like these built-in functions that helps us to like do tasks instead of just like writing them from scratch like we would do, like we used to do before. So libraries really make our life easy, especially like working with Python and working in fields like data analytics, data science, machine learning. So NumPy is just like one of those numerous libraries, and NumPy is just here to help us like manipulate numerical data. And what I mean by numerical data is like the sort of data we encounter in our everyday lives. So like sales data, hospital patients data, students information data, like data from the supermarkets and stuff like that. Those kinds of data is like numeric. And also there's other types of data like images that we would need to like convert into numerical formats to be able to use. So this is what NumPy helps us do. So yeah, Python has really made it easy for us with this sort of libraries and NumPy especially. And why would we be interested in NumPy? This is because of the wide range of functions that it gives us. So like, for instance, it gives us like mathematical functions that we can use to manipulate our data. It also gives us something called arrays, which is like either one-dimensional or like in many dimensions, and we'll be looking at this later. And it's also very easy to interpret, making it like very super fast. And please pardon me when I'm talking very fast, just stop me and like, yeah, thanks. So like, let's look at how to install NumPy. So like with any library at all, before we can use it, we need to actually like install it. And this is how we can install NumPy in our local machines and in Colab as well. So this is already satisfied, like I've already installed it. So this is why it's saying requirements already satisfied. Yeah, so I would continue with the types of data that we would normally encounter with NumPy. So like, just like any library, it deals with specific data types. And I'm sure you would have seen data types in the last class. So we can use NumPy with integers, which are like whole numbers, either negative or positive. We can also use it with floating point numbers, which people usually like refer to as the decimals. We can also use them with complex numbers. And this is basically like numbers that have like an imaginary part and a real part as well. So like this AI plus B type of numbers, those are complex numbers, and we can use that with NumPy. We can also use it with the Boolean type of data. This is like true or false data, yeah. And we can also use it with like lists, and lists are like basically like data structures that we can use to like store a collection of like numbers or integers or anything like that. So before we can use NumPy, we need to import it in Colab. And basically the way we import is like just like with the import statement, with the name of the library, and also with an alias. So the name comes in after the import statement, and then we have the alias that we are trying to give it to it. And this is basically just like sort of shortening the name, like another name we want to give to the library, so that we don't have to type the full name of the library like each time we have to like call the library to do any function. So here would import NumPy as NP, which people usually use. You can decide to use anything at all. So far as you can remember, it's like when you're trying to like call your functions. So let's look at the way we can use different data types in NumPy. So like, let's say if you want to like define a NumPy array, we have to use this np.array function here. And then basically like insert our array, and then we can also like specify the data type that we want. So we'll see like in details how to create NumPy arrays, but for now, let's just like look at the types of how we can specify data types in NumPy arrays. So here we have the integer array, which gives us like integers, and you can specify it as np.int32. We also have the float array. You can specify it with np.float64. And usually like when you just click on it like this in Colab, you can go to the source code online and everything, and then you can actually see how to use this in more details in case you don't understand. We can also have the complex type of array. So here you can see that our numbers have like the real and then the imaginary parts, and then we specify it with np.complex. Then we can have the Boolean type as well. So we just have true, false, and then we can specify it with np.bool. So basically, that is how we can use like different data types in NumPy. So now let's look at how to go from Python list to NumPy arrays. And I'm not sure if you saw Python list in the previous class, but like I mentioned, lists are just like sort of used to store a collection of data. So we store this like in a variable, and then we can manipulate it, we can access it. And lists have like just some unique properties, like they are ordered. This means that the items like appear in a specific order. And once you know the order of an item you are looking for in the list, you can actually just like retrieve it with that order. They are also mutable, which means that you can change like whatever is in the list. So for instance, you have a list of different types of foods in like Nigeria or something, and then we want to sort of identify a food from a particular region. If you know the order or like the index of where that particular food is, we can just call it and then we can change it. So that is one characteristic of lists. We can also duplicate the items. You can have an item appearing more than once, and we can also have different types of data. So like we can have in one list strings, integers, and like all these data types it talks about, like we can have all of them in just like one list, and that is totally okay with Python list. So now let's look at how we can create a list in Python. Lists are basically created with the square brackets. So like I want to have a list of these. I open my square brackets, and then I just put in the numbers I want. Then I assign it to this variable days. Then I can also have a list of just like strings. Then when you print it, you actually see that it's a list. We can also construct lists with the list constructor in Python. So it's basically like maybe this days list, we can try to construct it another way. So there's a function in Python called list, which you can use to like create lists. I'm not sure if I remember the syntax of it, but let's see. No. I think I would look at that later on. But like basically, this is one easy view of what list. Yeah, so like now that we've seen Python list, let's look at Python arrays as well. So aside from NumPy arrays, Python has like its own array function that we can use. But let's see how different this is from a list. So arrays are typically just like lists, just that they have like slightly different properties that they have that lists do not have. So like in lists, arrays can have numerical operations, but they are more like memory efficient than lists for some reason. And this is why we might want to use arrays for like a large number of data points. They also calculate like very few operations than lists. So it's like just more faster, like a faster version of it. So to create an array with the Python array module, this is basically the formats that we use. We import the array like we imported NumPy, and then we sort of specify its array.array. We have the byte code that we want to represent, and then we have our data type. So if you wanted to use like, let's say integers, for instance, this I would not work anymore. We have to know the byte code for integers, and then we can use that to create our array in Python. So like one source of difference between arrays and lists is that arrays cannot really like handle different data types like lists. So it's usually like somewhat difficult to manipulate, especially if you have like very big data points. So like I mentioned before, this would not work because we have strings instead of integers, and the byte code for strings is not I. So this might not work. Yeah, so like now let's look at why we might prefer the use of arrays than Python list. So let's create a list. We have the first list, we have the second list. So when we have this list populated with just random numbers, then we have another variable called results, which is sort of trying to like add the numbers in list 1 and list 2, not elements wise in another list, but like just as one integer, right? So what we are going to do is like we are trying to like measure the time it takes to like perform a calculation in list versus the time it takes to perform a calculation in arrays. Then we can sort of see how efficient it is. And this might not actually be really clear because the data points are just like a few. But when we have very big data points, you can actually tell what is happening. So let's try to add this element. So what we are trying to do is that we are going to loop through this list, then we loop through this other list as well, and then we add the elements in all of the lists. So what we do is like we go into the list, and then we basically just add them, like, yeah. So like we measure the time here, and then we try to do that with arrays as well. Then we measure the time here. So let's run this to see what we might have. So we can notice very slight differences in the time, though this is not like really clear. But when we have very large data sets, we can actually tell that the array are like much faster and like more memory efficient than the Python list that we have. So now that we've seen Python list and Python arrays, let's move to NumPy arrays, which is like our focus of the discussion for today. So NumPy arrays are basically like I said before, they are used for numerical calculations. So they provide us with more capabilities than the Python arrays that we saw before. And they are much easier to like construct and use. And like, it's just so simple if you use NumPy arrays, like to be honest. So NumPy array has like several characteristics that you might want to like check out and be interested in. And one of those is that it's like interoperable. So it sort of saves all the code like sort of behind the actual code that you are seeing. And this makes it like super fast to use. It also uses like vectorization. And this is basically like we saw in this sort of addition, we had to loop through. We don't really need to like loop through all these indexes in NumPy to be able to like sum and like do all of what we want to do. We just have to call our functions and then NumPy does it for us. We can also use NumPy for like a broad range of mathematical functions. We don't really have to do things from scratch, like let's say finding the square roots of every element in the list and stuff like that. NumPy gives us like a lot of functions that we can use to do this. And we can also use like different data types in NumPy. So unlike the Python arrays where we couldn't manipulate different data types, you can do that in NumPy arrays, and it's like very efficient and like very fast. Then we can also do additional operations like broadcasting and slicing, which we'll see in a bit. So let's look at how to create a NumPy array. So it's basically like I mentioned, like we imported NumPy as NP. So this means that we can always use np.array instead of numpy.array, just like in the Python arrays. So what we are trying to do is to create an array from list. So there are several ways of like creating an array. You can create it with like a square brackets and a brackets. You can also create it from like a list that is like already existing. So let's try to create an array from the days list that we had before. So we just pass this to a variable np.array. We open our brackets and then we have the list in here. So when we print it, you would see that this is actually like an array. So we can also create arrays from like built-in functions. But before that, like this might not actually be clear. So let's try to just like create an array, like not in with a predefined list, but like with our own list. So let's say I would name it as my array. And the syntax is basically, like I said, you bring NP first. You have your array, and then you have brackets like usual brackets. Afterwards, you need to have like a square bracket in this, and then you can start like passing through your array objects that you want. So let's say just 1, 2, 3, 4, 5 again. Then when we print my array, we would see that it's just like what we have before. So yeah, this is like just a basic way of creating NumPy arrays. And we can also create arrays in like several different ways. NumPy has a lot of built-in functions we can use. So for instance, we want to create an array of just zeros. We can use np.zeros to create this array. And when you click on it, you actually see like what it does. So we are creating an array of zeros of like just 5 zeros in like one dimension. So that is how we do it. Similarly, we can do it for just ones. And this is actually quite easy as compared to like typing one in every like sort of typing one in every like cell that you wanted to do. This makes it just like much more easier. We can also create array with values from a range. So instead of like typing from scratch that we want to create an array from 0 to 10, we can just have it like this with the arrange function. So np.arrange gives us like the opportunity to just like create it from any like list that we want to do. We can also create an array of randomly generated numbers. So for instance, we don't really want to have specific numbers, but we just want to generate it randomly. We can also create such an array as well. So here we have like random numbers, like just random initialized numbers. And one thing we have to notice is that when you create an array, like it's usually like in the format of floats like this. If you use the arrange function, it gives us like integers, but otherwise it just gives us like floats. And this is why our random numbers are like floats. Whereas if you wanted to create an array of random numbers which are integers, then we can use np.random.randint, which specifies that we want it to be integers and not the default like floats values that we want. We can also create an array with evenly spaced values. So for instance, we created this array from 0 to 9, and it was just like 0, 1, 2, 3 till 9, like it's just like the normal that anyone would think about. Now, let's say we want to create an array from 0 to 1, and like we want 5 values in it. How do we create this array? There are several ways of doing this. We can use the linspace attributes, or we can use the log space attributes. So here, what we do basically is specify where you want it to start, specify where you want it to end, and then specify like the number of items that you want in between. So let's see what happens here. So here, when we print the array with space values, you get 0, 0.25, 0.5. So what this does is that we are telling Python that we want array from 0 to 1, right? And we want 5 values. So what it does is like, it just like divides by 5 and then sort of gives us that. So when we take the end value minus the start value, we get 1. Then we divide this by the number of values we want. Then we get 0.25. And this means that at every point in time, it's going to be adding 0.25. So it gets to the last number and then making it the number of elements that you want in it. We can also use log, like maybe we want an array separated by log space values. We can just follow a similar fashion, like, and then have it like we have down here. Now, there's some common mistakes that people make when creating an array, and I'm just going to sort of comment this and try to let us think through what the mistakes are in here. So let me print A1. Can someone tell us in the chat what the mistake is with creating this array? And you can have an idea from the type of error we have, and let's see what happens. Yes, I see someone saying there's no square brackets and someone else says the parentheses. So like, if you look at the error, it says that array takes from 1 to positional arguments, but 4 were given. So like what this is saying is that we are not giving this like the right arguments that we need to give. And like I mentioned before, to create an array, we first start with So we first start with the parentheses, and then we bring in our square brackets, and then we create our array. So if you don't do this, it's not going to work. So this is why we need to introduce our parentheses in here. And now our array is printed. Now let's look at the second instance as well. It's a similar thing, but it's just like the order. In A2, we don't have the brackets, the parentheses before the square brackets, and this is also give us like an error. So we have to introduce that in here. And we have our array created. So this is some of the common mistakes that we have to take into consideration when we are working with arrays. Now, as we've seen before, the arrays that we saw was just like one-dimensional arrays, like vectors, just like in one dimension. But NumPy also gives us like a lot of varieties, like we can create multi-dimensional arrays. And multi-dimensional arrays are important because we sort of encounter that every day. We encounter like images, medical scans, stock prices, and stuff like that, which might not necessarily like fit into a 1D array. So how do we like sort of manage these data types? And this is why we need to use like multi-dimensional arrays. So Python gives us 2D arrays, 3D arrays, and I think even 4D arrays as well. But for now, let's focus on 2D arrays and 3D arrays and see how we can create them. So like if you want to create n-dimensional arrays in Python, it's actually like possible, just that it's sort of like from scratch, like I mentioned before. So here we are trying to create like an array, a 2x2 array, like a 3x2 array, and we want them all to have like 0, 0. This is how we try to do it. But now let's see how we can do this with NumPy. So the NumPy array objects, which I should have mentioned before, takes in like an object, a data type, and all of this sorts of like attributes. Like it depends on what your case is, like what task you want it to do, and then you can specify like which attributes you want in particular. So now let's look at NumPy 2D arrays, what they are, how we can create them, how we can access elements in this array. So like a simple definition that we can give to this is like an array of arrays. Like we have an array and we want it to contain other arrays as well. So like for one-dimensional arrays, we just have like one array, right? But in two-dimensional arrays, like we have an array and then we want it to have like other arrays as well. So that is just basically how it is done. So let's look at how to create these arrays. So the 2D arrays are just like nested lists that we have. Like we have one list and then we want it to have another list as well. So what we do is like just the same way we created the first array. We first open like our parentheses and then we have like our arrays in them, our nested arrays in there. So like you can see that we have just like one square bracket that contains both of the arrays in it. So I don't know if I'm explaining this very clearly, but I really hope that it makes sense. You have your parentheses, you have like your brackets, which is going to contain your nested list. And then in that brackets, you have like the number of arrays that you want to have, because 2D arrays are like arrays of arrays. And basically that is how we do it. So here, when we print the type of this, you see that it's a numpy.nd array, like it's a multi-dimensional array. You can also have an array of like tuples of tuples. So like, let's say if you have nested tuples, tuples are just like less but slightly different. So let's say to create a tuple, what we do is just like have parentheses and then we have what we wanted to have. So this is basically like a tuple. So to create like a tuple of tuple, we just come in here, add another tuple like this, and that is it. So to create an array from tuples of tuples is just like the same way that we do. And we can specify our data type as well. So like we saw in the beginning, we specified like the different data types we wanted. Here, when we specify that we want complex, this is what we get. And this is also like a way of creating an array. So like you mentioned, there's a lot of built-in functions for creating arrays. 2D arrays are like no difference. We can use np.zeros. But here, what we can notice is that we just don't pass one value like we did in the one-dimensional arrays, but we are passing like two values because we want it to have like rows and columns. So like we can see in this image, 2D arrays have like rows and then they have columns as well. So that is what we have to specify in this instance. So let's say here we want to create a 3x4 array and we want it to have zeros. It's just the same thing we did, but now it's like specifying the number of rows and columns that we want in there. So when we have this, would have np.zeros, would have 3, would have 4, and then would just like that would have like a 3 by 4 array with zeros. So that is what we see down here. And now let's try to create an array of ones with integers. It just follows the same function. Like we specify the data type to be integers. We can also pass in shape instead of just passing in the parentheses with the rows and columns as well. We can also create an array that's like has let's say elements that are not like initialized. So maybe for now we don't want to have zeros or ones, but we just want it to be like randomly initialized values. We use the np.empty, which you can see. So there's like a whole lot of this, and you can find it in the Python documentation. I think I left a link down there so you can see this. Yeah, and we can also have like an identity matrix. So the identity matrix is just like np.i, and then you just pass one value because the number of rows is equals the number of columns. So you don't really need to specify like both of it. You can also have arrays that has like copies of the shape of the other array. So for instance, let's take this array E. So E is just like a list. Sorry, I didn't make this into an array. And then we want E to have like the shape. We want another array called copy E to have like the shape of E. So E, as you can see, is like 2 by 3, 2 rows, and then 2 columns, right? So that is what we want to do. So we can easily do copy E and then do np like zeros like. So what we are trying to do with np.zeros like is like we want an array which is full of zeros, and then we want the shape to be like E. So that is exactly what we are trying to do. So when I run this, would see what happens here. Yeah, I changed my runtime, so I need to import NumPy again. Sorry about that. Yeah, so this is what happens. We have the array that is like this. This is the E array, and then we want the copy of the original array with zeros. Don't know why this is not working. Did I print copy E? No, I printed copy E the shape. Sorry. Yes, so this is the original array we had. Now we want to have a copy of this original array like filled with zeros. So like we use np.zero like, and then we pass the original array whose shape we are trying to copy, and then we have it. And we can also have an array like filled with a particular value. So let's say we want arrays that has just 7 everywhere. So what we use is this np.full. We pass in the shape of our array, and then we pass in the value that we wanted to have. So here we just bring a comma sign after the array, the shape of the array, and then we have the number we wanted to fill it with. Another way of doing this is just using like np.ones, right? And then we multiply it by 7. And this gives us what we are looking for. So this is the array filled with 7 that we use np.full to do. We can also use np.ones and multiply it by 7, and then we have the same thing. So now let's see how we can create sequences of numbers. We already saw the arrange function, and basically this is just like the arrange function for like 2-dimensional arrays. So we use np.arrange, we pass in the sequences that we wanted to have. So we start from 0 to 100, and we wanted to have like a step of 2. And that is what we get. So with np.arrange, it starts from 2, and then it goes all the way to like 98. So we can notice that if you use np.arrange in this fashion, it doesn't include the last elements, but it includes like the first element. So this is what happens. Now let's look at what happens if an array is too large to be printed. So we are saying that we want an array from 0 to 10,000. If this is going to appear, we'd have to keep scrolling and scrolling and scrolling. So what NumPy does is that it just starts with a few numbers, and then it ends with a few numbers. And then it brings in this 3 dots to show that there's several elements in between it. So for instance, you are trying to see like, you are trying to like change an image from like the normal image into like pixel values. And then you print it, and then you see something like this. This doesn't mean that this is all the pixels. It just means that there's something in between, but like it's too large for NumPy to print it. So it does this for you. Now that we've seen 2D arrays, let's try to take a look at NumPy 3D arrays. So before that, I want us to do a quick assign like a quick exercise. So what we want to do is sort of like create a 3x3. A 3x3 array with all ones and 0 in the middle. Let's see how we can do this. And if anyone has an idea, please put them in the chats. So someone says np.01. Let's try this. So this is not going to work because the syntax is wrong. I don't know if it's from the copying, but basically we imported this as NP and it's case sensitive, so it has to be like this. Also, the zeros has like a small letter, so it has to be like this. And there is no E as well. So let's see what happens when we run this. Also, this is not subscriptable like we mentioned. This is like the parenthesis has to come before the square brackets. So this would not also work. So we'd have this instead. So let's print this to see what we are going to get. So this doesn't work. I don't know if other people have other ideas. So I see quite a lot. Let's try this as well. Yeah, so this works, but this is not what I'm looking for. Can we find a more efficient way of doing this with the attributes that we mentioned before? So let me try one last one, and then we can try to solve this. But this is a very good idea, but this actually takes time. So I'm trying another one here. Let me print that to see what we have. And this works. So this is actually what I was looking for. And I don't know who put it in here. I think that was Daniel. Thank you, Daniel. This is actually what we are looking for. So we can see that between these two different answers that we had, they give us the same answer, all right, but the way we arrive at the answer is actually like what really matters. When you are working on like very large data sets, you want to consider like efficiency and time as well, because you don't have like a lot of time to do like a lot of tasks. So this is why a lot of this sorts of functions like np.1s, np.0s appear, and then we can use that instead of like trying to type in things by ourselves. So what Daniel is doing here is that he created this array 3x3 with like ones everywhere, right? But then we are trying to change the middle, just the middle value to 0. So what he did is like he tried to access the index of the middle value, and then he changed that to 0. And remember we said that arrays are like mutable. You can change objects in lists just like Python list. So this is actually what he did by indexing, and we'll see what indexing means like in the coming slides that we have. So now let's look at the 3D arrays. And the 3D arrays, like we said for 2D arrays, they're like arrays of arrays, right? Now, what do we think about 3D arrays? Are they also going to be arrays of arrays? Well, they are, but it's actually like now arrays of like 2D arrays. So it's like anytime we go, we sort of like have something, we have like the other step in between. So like for one-dimensional arrays, you just had numbers, right? For two-dimensional arrays, we had like arrays that contained arrays. Now for 3D arrays, you are going to have arrays that contains 2D arrays. So can anyone guess for 4D arrays what we would have? Yes, thank you, Delamore. Sorry. Yeah, so Sarah got it right. 4D arrays contain arrays that has 3D arrays. So that is how we are going to start moving from now on. So like we said, 2D arrays had columns and rows, right? But like 3D arrays are now going to have arrays that have like the rows and the columns of other arrays. So like we have first 2D array, we have a second 2D array, and then we have a third 2D array. So it's basically like multiple copies of like 2D arrays. I think someone raised a hand. Please go on. So like 3D arrays, like it's just like I said, like an array of 2D arrays. So let's see how we can create this. So I'm just going to put a code here and try to create like a 2D array. So like we said, a 2D array is created with like parentheses. So like you can have array 2D is equal to like parentheses 1, 2, 3. Then we have another array in it. 2, 1, 3. So this is what we have. And now we are trying to like have several of them in there. So let's see how we can create a 3D array. So to create a 3D array, it just follows like the syntax of NumPy arrays, just that this time, like after our parentheses, we have like a 2D array, we have another 2D array as well. So let's see how to create this 3D array. We have our np.array, which we have already. We have our parentheses, which are closed. Then we now have our 2D arrays in them. So the first one would be consistent of like a 2D array. So this is just one 2D array. This is another 2D array, and then this is another 2D array. And that is how we move. So we now have the 3-dimensional array. It has like several 2D arrays in them. So you can notice that it first starts with this brackets, which are closed. Then you have the 2D in them. So now just to visualize what a 3D array might look like in real life, let's try to look at this. You don't need to know Matplotlib or any of those libraries. I'm just trying to demonstrate how a 3D array might look. So it's sort of like an image. So images have like, they have their height, they have their width, and then they have their channels. Like images are typically made of red, like blue and green. So that's what we are trying to do with 3D arrays. So now that we've seen how to create 3D arrays, let's look at 4D arrays. And you can also create them with np.zeros and stuff like that. Just that you have to like specify what you want it to contain. And now 4D arrays are not like usually encountered in like beginner ML and stuff like that. But let's just have a fair idea of what it should look like. So 4D arrays are like a bit complicated, but let's just see how they should look. So now we have like a 4D array, which contains like 3D arrays and another 3D array. And let's try to move from there. So we still have np.array. We have our 3D array like we had in here. Then we have multiple of these 3D arrays, and this is what we are doing over here. So you now see that when you print it, you have several like 3D arrays instead of 2D arrays like 3D ones. Yeah. So like this is example of like a 4D array. So this is a batched image. And it's sort of like you have an image that has like several batches in them. And basically that is what 4D arrays look like. You can encounter this sort of data in like MRI scans and like all those scans that come from like medical imaging. So now that we've seen, we don't really need to look more into details with 4D arrays because this is not there. Like we have a lot to cover. So I'll just move on to the array operations that we have. So let's look at basic operations that you can perform with array. And there's like a full list of these operations on the NumPy website. So after this class, concepts that I didn't really explain well or concepts that you didn't really understand, you can just go to the website and then you can have like a feel of all of those. You can try experimenting with them or not. Yeah. So here we are going to create an array called English, like a one-dimensional array. We create another array of integers. Remember I mentioned this random integers. If you had just had np.random.rand, it should give us random numbers from 0 to 100. with steps of 10 with no sort of like with just like float numbers. But when we specify round ends, this means that we want it to have integers. Then we want grades to be like a zeros array, which has the same shape of English, like the same shape as this, right? So let's see what happens here. So we have our English array, we have our math array, and then we have like our grades array, which is basically like zeros, like we specified it to be. Now we can do elements-wise addition, subtraction, and all of that is arrays. We don't really need to go and loop through to find all of this. So what we are trying to do is that we have this grades array, which is like zeros, right? We want it to contain the addition of English and maths in it. And this is the English array, this is the math array. So what we do is just use the plus sign. We don't have to like go into like loop through like we saw with Python list before. Array makes it like so much easier to manipulate. So we can either just use the plus sign and then we have it, or we can use the np.add sign. So this is also mathematical operations that NumPy gives us. There's a lot. We have like multiplication, for subtraction, for finding the minimum, the maximum, and all stuff like that. So you can either just use plus or you can use np.add. Then you have the same answers in all of them. Now let's look at multiplication. It follows the same fashion. But if you notice, what we are doing here is just like elements-wise multiplication. It's not like the matrix multiplication we have. Now let's look at how to do like the matrix multiplication in NumPy. So to do this, we don't use np.multiply or like this star sign. What we need to use is the add sign. So let's say we have this array, 2 by 2 array. Then we have this array as well, the A and then the B arrays. Now we want to have an elements-wise product. Let's see what happens with the star sign. What we are seeing here is just like the values being added like elements-wise. So like we have 1 times 2 giving us 2. We have like 1 times 0 giving us 0. So this is like, if you try to use this for like a matrix multiplication, what she gets is like very wrong values, because we are trying to do matrix multiplication, which is not like elements wise, but like sort of follows like a particular pattern. So let's see what happens when we use A times B. So we notice that with matrix multiplication on this notebook, it might not really be clear, but what we are trying to do is multiply like 1 times 2 plus like 1 times 0, and then you add them to get your values, and then we do that like in all the instances to get this. So this is why we are getting slightly different values from here, because over here we are actually doing matrix like multiplication, but over here we're just like multiplying the elements like elements wise like we did. And we can also use the dot function to do multiplication. This gives us the same answer as well. So you can also use np.dot, or you can just use a.dot, which is like a module in Python that you can use. And it's like the same for subtraction. You can either use just the minus sign, or you can use np.subtract. And this does it for you like elements wise. So you can see that where we use the minus and then where we use the subtract, there's actually like no difference in there. And NumPy also has several other mathematical functions. They are actually like a lot. We have the arrange function, and we have the square root function that you can use, or you can just use like your usual Python multiplication. Sorry, your usual Python square roots. We can also have the print, the power function. Instead of like maybe m star star 2, you can use np.power. And then you can get the powers of all the elements in a particular list. And there's more operations that you can always do with Python, but you can look at them from the full website of NumPy. And there's like a lot, depending on the task that you want to solve. But let's look at this. So here we want to like draw an image, right? And we want it to be of the form of like a NumPy array. So what we are doing is that we are specifying this image array, which has like random integers from 0 to 256. So we know that black and white images, like people that are not in computer vision might not really understand. And you don't need to understand this. I'm just trying to demonstrate like how to use arrays. So black and white images are typically from the range of 0 to 256, where 0 is like the very light pixels and like 256 is like the very dark pixels. So we wanted to have a 10 by 10 size. So that is like the size of our image. and we want the data size to be like integers. Now we can use some libraries to like plot this image just for visualization purposes. And this is what we have. And now we can try to find like what is the minimum pixel in this image. So we can use np.min. This is used to like find the minimum images. And when you click on this, you can actually see like what you're supposed to use with it, like I mentioned before. So here it tells us that the minimum pixel value is 8, right? We can try to find the maximum pixel value, which is like 249. And this like keeps changing because we like generated it randomly. We can also try to find the standard deviation from it. We can try to find the mean as well. So by default, like you can apply this to a list of numbers. Like if you have numbers stored in like CSV files, we can always like just apply this. So when we print the image array, you see that it's just like this. But because we plotted this, we're able to get it to appear like this. So this is just like a normal array, like a 2-dimensional array. Now we can also try to print like the maximum value on each row using np.max. We pass in our array, and then we pass the axis. So the axis is saying that we are trying to find like the maximum value on just these columns. If you wanted it to be like on just this row instead, if you wanted it to be on like the columns, you can actually use 0 for the axis. So it's usually like either 0 or 1. And there's a lot of functions to cover. You can have like the OR function, the argmax, the argmin, how to sort values with argsource. We have average, like there's so many of them as you can see here, and all of them are contained in the docs. Now let's look at broadcasting operations in NumPy arrays. So like when we are working with very high dimensional data, we sort of refer to them as arrays, or as tensors, because like this has so many arrays like packed in one. So here, what we are trying to do is like, we have an array, which is just ones like of 75. This is just like a 1-dimensional array that we have. And what we are trying to do is sort of like break this down into like a 5x5 arrays, 3x5 arrays instead. And we want all of them to have 1. So what we are trying to do is to use this reshape. So np.reshape gives us like a way to sort of like restructure like 1-dimensional or 2-dimensional arrays into another dimension. So we have this np.ones, which is 75 over here. This is just 1-dimensional array of like 75. But now what we are trying to do is to have a 3x5 array out of them. So usually when you are using reshape, you have to be careful with how you like calculate, or else it's going to give you like errors. You have to know how to like really like have them shaped. So we can have this. So imagine we wanted to have like 6x5 arrays instead. This might not work, and we have to like sort of redo it again. So here we have our arrays being reshaped into this like 5 arrays. So 5 arrays of like 3x5. And you can notice here that the rows, so the rows comes here. So you have like the number of like reshaped arrays that you want, which is just like 5. So you have 1, 2, 3, 4, and 5. Now we want it to have 5x3 shape, right? So we are now going to have like 5 rows, like 5 rows on each array, and then like 3 columns on each. Now let's try to create a 2D array. So when we create this 2D array from scratch like this, we are trying to like add a scalar to the entire array using broadcasting. So like here we have this just having 1, 2, 3, and then 4, 5, 6, right? But what happens if you want to add 10 to like all of the values in here? And this is actually where broadcasting comes in. So broadcasting allows us to like add scalars to like all the elements, or like maybe just the elements on like 1 dimension. So like after broadcasting, what we now have is like 10 is being added everywhere. And you might be wondering, did this just add like 10 to all of them? So what it's actually doing is that broadcasting creates like another array, which has like 10 with the shape that you have already. And then it adds it like elements wise. And that is basically like what broadcasting does. So now let's look at this other example as well. So here we have array A, which is like 3 by 2 array, right? We have another array which is just like one dimension. So now I want to add this 1D array to each row of this array. Let's see how this is going to be done, right? So now we have just like array of different shapes. How is this going to be done? So what Python broadcasting does is basically like, it adds like another dimension here. So like it just copies all of this once to produce another array of this, so that it can add them to this like directly. So that's what it does in here. So the original array had this values, then the original 1D array had this value. So it's to sort of duplicate this array, add it to the first one, and then add it to the second one, to the second row as well. And that is what broadcasting does. So now let's look at indexing. So indexing is just basically like a way to access like elements in like any array at all. So what we are trying to do here is like, we have an array here, which is just like names of people, right? So let's say we want to have the first name, which is Stephen. What we can do is try to access this with the index. So the index usually starts from like 0 and not like 1 like we think. So like, let's say this element will have index of 0. This would have index of 1, index of 2, and then index of 3. Unlike we thinking that it should have indexes of 1, 2, 3, 4, it usually starts from 0. So if we want to access this element, we have to pass this index here. And what we typically do is just like have the name of the array that we have. Then we call the index with a square bracket, and this would print it for us. So this is exactly what we have in this print statement. If you want to have the index of this elements, or this elements, we have to know like where the index is. So we have 0, 1, 2, 0, 1, 2, 3. So when we pass in 3 here, we actually get this element. And that is basically what indexing does. Now there's an advanced way of indexing as well. So let's say like we create a sequence of integers from 10 to 1, and then we have like negative steps. Let's see what this prints. So like we specify that when we want it to have like a step, it needs to be positive, but we can do this with negative instead. And this goes from like the first direction to like the end of it. So instead of having from 2, 4, 6, we now have from 10, 8, 6 up to 2, right? Now let's try to have another array like this. So we have our array called like our array which has the values of 3, 1, 2. And you can see what we are trying to do here. So what we are trying to do here is like, we want to like take out the indexes of this particular elements from this first array, from this index array, right? And this array was what was printed down here. And we want the elements here. So like the elements are 3, over here is 6. Sorry, it's 4. So because you have like 0, 1, 2, 3. So it's 4. The elements as 1 would be 8, because like the index is like 0 and 1. And then the index at 2 would be 6. So this is why we now have like 4, 8, 6. So you can also index like multiple like indices as well. And the way you pass this is that like you have this array, you sort of pass this another array in to access the elements that are in this array. And then when you print that, you actually guess what you are trying to do. So now let's look at this other array. So when we have this other array, we are even passing like negative indexes. So let's try to see what it should print. So before it actually prints, what we are saying is that we want from this index array, we want this particular elements, right? So you want the elements at 1, at 3, and then at minus 3. So let's look at that array over here. The elements as 1 is 8. The elements as 3 should be, I think, 4. And then the elements at minus 3 would now go backwards, and that should be like either 6 or 8. So when we print this, let's see what we get. So we have the elements at 1, which is 8. We have the elements at 3, which is 4. And then we have the elements at minus 3, which is 6. So we have minus 1, minus 2, and minus 3. So the negative indexing doesn't start from 0, but it starts from like from 1, and then it goes backwards. So basically that is how to index, either with just like one value like we saw here, or with multiple values passed to another array, like we saw in here. So this is sort of what you have. So now that we've seen this, let's look at another form of indexing called the Boolean or like the max indexing. So this is basically like trying to like index a particular condition. So let's look at this numbers array. Our numbers array is like a one-dimensional array of 25, which has been like reshaped into 5 by 5. So let's print that and see what we get. So basically we have 25 values reshaped into like an array of like 5 by 1, of 1 by 5 instead. And now what we are trying to do is like specify a condition. So here we want to have another sort of like array called boost, and we want boost to have numbers that are greater than 20 and numbers that are less than 22. So that is from this array. We now want to like take the elements in this array and then just like extract the elements here that are greater than 20 and then the elements that are less than 22. So basically what we want is just like this one, this particular one, right? So we can write this, and then this is what we get. So the answer we get is just like a replica of this array, but instead of the values that we had, what we are now getting is like the Boolean values. So like, is there, let's say a false in here, like, is this condition being satisfied on all the elements? Like, so it goes through like every position. If it's satisfied here, it's true, otherwise it's false. So like we specified that we want numbers greater than 20 and less than 22, which means that we want just 21. So it means that every other element would be false apart from where the condition is satisfied, which is where we have true. So if you notice here, the 21 position has true and everywhere else has false. So like, let's try to make it a bit clear with like a lesser condition. So let's say we want all elements that are, let's say greater than, maybe greater than 5. Greater than 5 and then less than 22. So this is 5. So all the elements from this 6 all the way down here should be true and every other element should be false. So let's see what happens when we run this. So we can now see that all the elements from 0 to 5 are false. All the elements from 6 to like 21 are true. And then the rest of the elements are false as well. So this is basically how the max indexing works. So now when it prints, we want to see like which elements satisfy the conditions instead of just like true and false, true and false, true and false. It's actually printed like this. So like you have to pass this Boolean mask into the array that you first like defined here, and then you get this sort of real values instead of like the Boolean mask that we saw before. So now let's see how can we like index along like multiple dimensions. So let's take a look at this array. So we have like our 3 by 2, 2 by 3 array in here. Pardon me, I keep confusing this thing. And we are trying to index this with 0 and 1. So let's see what happens. So what is happening here is that it first goes through the row 0, which is like 1, 2, 3, and then it gives us like the first elements. So let me bring this out of here. So this is the array that we are working with. We want to index with 0 and 1, but remember that this is like multi-dimensional, right? So what it does is that it first goes through this row. Like it enters in here, goes through row 0, because this is like the index. So this is like row 0, this is row 1. It goes through row 0, and then it gives us the elements, which is 1. So this is why we are getting 2 as our answer. Now let's look at this. So here we are saying that we wanted to look at all the rows. The first value is like depicting the rows, right? We wanted to look at all the rows, and then we wanted to return the elements that are at like position 1. So this means that it goes through like this row, returns the elements at position 1, goes through this row, returns the elements at position 1. So when we print it, this is what we are going to have, 2 and 5, because this is the elements in there. So this is basically like saying we want the column 1. So now let's try to look at slicing as well. So slicing is also just like indexing, but instead of like maybe getting elements one by one or like getting like elements by indices, we want to specify like a range, like from a start to a stop, and then we guess what we are trying to find. So I think there are some questions in the chat, but after I'm done with slicing, I'll try to look at them before moving on to the next session. So let's look at slicing in just like one-dimensional arrays. We have an array starting from 0 to 100 with step size of 10, right? And this is basically the array. Now we want to select our indices, like elements that are like at the indices 1 to 6, right? So basically what we are trying to get is this, like from 10, 20, 30, 40, 50 up to this. So let's see what happens. So with slicing, like we don't just specify elements with a comma, we try to find like elements in a particular range. So like now that we have this array B, what we are trying to get is like the elements from like array A, like array B is like another array, which is like array A, which takes the elements from like the indices 1 to 6. So it starts from the index 1, index 2, index 3, index 4, index 5, and then it ends there. It doesn't include the index that is specified at the end. So this is why we are getting 10, 20 up to 50. Now let's say we want to get the elements from the third indices, right? So like once this is index 0, index 1, index 2, index 3, we want to get all the elements afterwards. So the way we sort of slice is just like, just pass that first one and then we have our colon. Then it gets us all the elements like going forward. Now let's try to see if we want the elements from like not starting from here, but like all the elements to a particular point. So we are trying to slice like this. So like array D is now like, we start with the column and then we end as 5. So it doesn't include 5, like I mentioned. It starts from 0, 10, 20, and then it sort of like ends here before the index, like the elements as index 5. And we can also use like negative indexing as well. So let's see what this does. So here we are trying to say that we want elements from the negative index, so like from -1, -2, -3, -4. So we want from 60 to the index at -2. So let's see what happens in this particular example. You see that we have 60 to 70. So it started from 1, 2, 3, 4. This is like the negative indexing. And now we say that we want -2 as well. So it just takes like this 2. And that is what we have. Now we can also use like a step value. So what step values actually do is like they skip elements, like they sort of bring the elements that you want, but it's sort of like stepping in a particular fashion. So now we want to get like this index of like 2 columns and then 3. We want it to like start at like 1 part and then like skip in between, like skip 2 values in between. So this is why we have like 30. We don't have this 2, we have 60. Then we don't have this 2, and then like we have 90. So that is how like this sort of indexing goes. So you can use a step value, and the way you basically do it is like this 2. So like what we have covered so far is like you can index from like one point to another with what we are doing here. You can index starting from one point to the rest, which is like you first have your number, then you have your colon. You can index from the start to a particular point, and in which case you have like your colon, then you have where you want to stop, right? Then you can index like in the negative direction as well. And then you can also index with like a step size. So for instance, if I had 2 in here, it should return the elements, keeping like 1 element in between. So we see here, we now have like 0, 20, 40, and then like so on. Like, so this was our array A. So we now have 20, would have 40, would have 60, and then would continue in that order. And we can also slide along like a particular interval. So let's say we want to start from 3 and then we want to end at 4. We can take the elements just like at this index and then at this index as well and skip all the rest. So this is why we have 30 and 70. So we are specifying that we wanted to have 3 and 4 and skip the ones in between. So this is why it sort of starts here as element 3, skips the one in between, and then it gives you the final one. So it sort of skips like 4 steps and then it gives you this. So now let's see how to slice 2D arrays. So let's consider this array, which has like 3 rows and 3 columns, right? And now we want to select the row with index 1 and the elements on the column of row 1. So like we saw earlier, that was like selecting like the columns. Now we want to select the row. So let's see what's happening. So like we are saying that we want this like row with index 1. So this is like the middle one. And then we want the elements on the columns of row 1. So it would give us, I think, 5 or so. So it gives us like 4, 5, and 6. We want this row, and then we want all the elements on this row. We want all the elements on the columns of this row. So we have 4, 5, and 6 as the columns that we want. Now we want to select all the elements on the row of the third column. So the third column has index of 2, right? So now what we are trying to do is like we want to select all the elements on the row of the third column. So let's see what this gives us. So this gives us 3, 6, and 9, because this is the row. So the row is like, we want all the elements on the row, and then we want all the elements on like this column. So this gives us like 3, 6, and then 9. Then we can also do like 2-dimensional slicing. So like, let's say we want to select row 0 and 1, and then we want to select column 1 and 2. So that is basically like this row 0, and then row 1, and then we want to select column 1 and then column 2. So let's see what happens. So like row 0, row 1, column 1, column 2. So I think this is like what we are trying to find, this 2 and 3, and then 5 and 6. So this is what we get here. And we can also do the same thing with like using the steps like we did before. So we can come in here. So we want to select every other row and column apart from the one at index 2. So what we are trying to do is like select every row and every column apart from the one at index 2. Apart from the one at index 2, so like we are trying to get the 1, 3, and then the 7 and 9. So we want every row and every column, but the ones at index 2, we don't want it. So we sort of like cancel this out. And then we get this. Yeah, and it sort of like just follows the same one. So like here we want to select from rows 1. So like that is the second row, right? And the columns 1 and 2 of array 2A. And this is like basically array 2A. And we want to have like the elements in here. So this is how we try to slice it. And all of this is sometimes confusing. Like no matter how many times you do it, it can really get confusing most of the time. So you really have to like try to write it down, try to find the position that you want, and then that's where you can just pass it and then you have it. Now let's look at how we can slice 3D arrays. So let's consider this array B. So we sort of have this like this sort of like 2D arrays being stacked in a 3D array, right? So let's see what we want to do. Here we are saying that we want the first, like the row here, then we want every other thing on that. So I think it should try to select this one. I'm not sure though. Yeah, so it tries to select this. So what it's doing is that it first goes into like the 2D array. So this one specifies the 2D array that you want, the index of the 2D array that you want. And then the second one shows that you go into the rows and the columns of the 2D array you want, and then you now specify what you want to pick out from there. So let's say we want the first one. We just change it to 0. And then we get this first one. So like, let's say we are trying to access the second row of this first one. Let's try to change this to the row to see what happens. So here we have the second row. So we've gone into like the first one, the first 2D array. We've gone into like the second row of the first 2D array, which is indexed by 1. And then we print all the elements in there. We can also do it in multiple directions and like multiple dimensions and see what happens. So now we are saying that we want to select like the layers, like we want to go in here, right? Once the elements, like once the arrays from 1 to 3. So that's a sort of like the index from 1 and 2. So it considers this one, right? Now what we are trying to do is that we want the first one, no, the second one instead, and then we go in that order. We can also use try to like select every other layer, like all the rows and like every second column. We can do a similar thing here. So we go into first layer, like the layer 0. We select the second row on that first layer, and then we select row 0 and then row 1. So now that we've covered this, I think the next thing is to work with Pandas and then scikit-learn, and we are done. But for the meantime, I would pause to look at any questions that we have. I think it was just conversations, right? So I can go on. Yes, that's right. So the first slicing targets like the first 2D array that you want, then you can go in there. Okay, sure. So let's start here. And usually the way I try to understand like slicing of 3D arrays is by writing with a pen and paper. Like if you draw out your matrix and then you have your 2D arrays in there, you can try to sort of like look at what you are trying to do. So this is our 3D array, which has several 2D arrays in there, right? So now what we are trying to do is that we are trying to find the first, like when you try to slide like along the first dimension, it takes you into the 2D arrays and selects the index. So like now we have 0, 1, and 2. So like just look at only the 2D arrays that you have for now. So we have the one at index 0, which is this. We have the one at index 1, which is this. Then we have the one at index 2, which is this, right? And we are saying that we want the first one. So this is why it takes like we put in 0. Now that we are in the first one, we want to go into like this first one, right? So now we are saying that we want 1, and this first one has just 2. So it has like index 0, which is the row, index 1, which is the second row, right? So now we are saying that we want index 1. So we've gone into like this first 2D array. So we had three 2D arrays. We've gone into the first one. So that is the first dimension, like going into the particular 2D array that you want. Now that we are in the first one, remember that for 2D arrays, we had rows and columns, right? We now want to go into like the rows of the first one. So this is why we specify 1. Now that we are in this row, which is like the row with the index 1, we now want to like find all the elements on that row. And we have this, so this is why we get this. So I don't know if this makes sense. So this is why we get this particular element. So say now that we are in the first row, we want to get, say, this element. Let's try to put 1 there because the index in there is like 1. See what happens. You see, we have 5. So we've specified that we want to go into this particular one, this particular 2D array. Now that we are in this, we want to go into the second row, which is the one with index 1. So this is how we go in there. And now we want to find the elements at the column 1. So this is what we have. And this is selecting the whole thing. So like, let's say we are trying to find this. Let me just comment this out. So let's try to access this one. And then let's try to find just the column. So what we are trying to do here is like we have B, we have our brackets. And now we are trying to get into this third 2D array. So we know that the indices are like 0, 1, and 2. So we are going to specify 2, right? So let me try to print 2 and see what we have. We see that it prints this one, the 2D array. So after printing the 2D array, what we are trying to do is go into this particular one. We want to find this 2. So we now have this already, right? So we are trying to find the columns. So like this is the rows and this is the columns. So the rows has indices 0, like 0 and 1. The columns has indices 0, 1, and 2, right? So let's try to find this particular column. No. Yeah, so we have this. We are now trying to find like all the elements here. Let's see what it gives us. So I selected this particular one. Let's see how to choose like the columns. No, this is not what I'm trying to do. So I'm going to go into this particular row. No, all the rows. And then I'm trying to find this particular one. So it gives me 14 and 17 because I specified this. So like now I'm in this particular 2D array. I want to find like this, all the rows in here. So this is why I have this. And now I want to find the center. So the indices here is 2. So I'll just go put 2 and then I get 15 and 18. So I don't know if this sort of clarifies how to do it, but basically this is it. And we can try to do it along multiple dimensions as well. So here we are saying that, let me just copy this again so that it's not confusing. So this is our B again, right? Now we want to select this 2D one. We want to select this 2D one. And then we now want to select the first row and the columns of 1 and 2. So let's see. So what we are trying to do here is like first get the particular ones we are looking for. So when we start with 1 and 3, it gives us like the ones that's indices 1 and then the ones that's indices 2. Remember that's like when you are slicing like with multiple, it doesn't include the third one. So we don't even have 3, so it wouldn't include it. Now as we want to select the first row of both of them, of this and this. So this is why we have like 0. And now that we are on this row, we want the columns 1 and 3. So it's going to give us like 8, 9, and then it's going to give us like 14 and 15 because like this is the column like 1 and this is the column 2. So it's going to give us like the first row of this, the first row of this. And this is why we are having this. So I would like to explain it more, but I think this is what I can do. And I need to move to Pandas and Scikit-learn, and then we can finish up. I hope this makes it clear, though. Yeah, thank you. So now let's try to work with CSV files. So CSV files, like the name suggests, they are like comma-separated values. If you are working in like data analysis, machine learning, this is like one type of file that should always encounter because this is like very easy to manipulate with NumPy. And basically this is how it looks like. So we have like the name, like let's say we have this as like headings. We have this particular information in like all of the columns. So like the columns are separated by comma. So you have like the columns that you have in here. So you have name going with the names, you have age going with the ages, and like it goes on like that. So let's see how we can create CSV files from like arrays. So here to do it is like actually very easy. Let's say we have an array like this. So like we have 2-dimensional arrays like this. This is one dimension, this is another array, and like so on. So the way we can do it is just like specify the name of it. So like this is the data, and then we can save it. So we sort of save it as like the file parts. Then we have the content, then we have the name, and then we just add CSV to it. So this is the name of our array, right? But we just add CSV to it to make it into like a CSV file. Then you can save it like to your computer. And this is what this is doing. So to save it, you use this like np.savetext. That is basically how to save CSV files. Then you have the file path, you have the data. Then you have this to show that you want it to be separated by commas. And then basically like just like format it the way you want it to be. So now let's try to print this array. So when we print it, we see that we have like a 2-dimensional array like this, right? So then how do we see this? Like after saving it here, because I'm in Colab, I'll find my CSV file here. But I can't just open this like this. So to open this, we need something called Pandas. And like just like NumPy, Pandas is also like another like library in Python. And it allows us to like work with CSV files, like manipulate them and do whatever we want to do with it. So let's see how to open it with Pandas. So Pandas, like any other library, is very fast and efficient. It helps us to manipulate CSV files. It helps us to like manipulate data frames, which is like objects of like CSV files. We can like handle missing data in the CSV files. We can do slicing like we saw. We can do indexing. We can group the data and like basically get any sort of data that we want. So let's see what's like the data types of Pandas is. So like Pandas usually works with two main data types. One is the series data types, and series is basically like a 1-dimensional array, just like we saw. So series is actually like very easy to like work with. So to use Pandas like any other like library, we could see that like I imported NumPy. So I just have to import Pandas as well. So now that I've imported Pandas, I want to create a series, like a 1-dimensional array. So I just use this pd.series function. I pass in the data that I want. And one main difference between like series and then like Python 1-dimensional arrays is that like with series, like we didn't really get to specify the indexes that we wanted. But with Python instead, we didn't get to specify the arrays, the indexes we wanted. But in series, we can actually like sort of just pass it in to make it easier for us to like be able to reference. And you know, when we're working with like 3D arrays, it was very confusing. Like we have to start the indexes from like 0, 1, 2, 3. And sometimes you forget that instead of like starting from 0, you start from 1, and it's very confusing. So with series, we can actually like specify the index that we want. So let's say here, I've created my series objects like with pandas.series. So it's like randomly assigns it like this one because I didn't specify any index that I wanted. And when we look here, we say that we pass the data and then we pass the index. So when you pass just your data without the index, Pandas automatically gives it like just like this sort of like indices that you can see. So you can also have like a series with just one particular one. So here, what I'm doing is that I'm saying that I want a Pandas series. And you have to note the capitalization here. So this is actually like capitalized. If you don't do it in this way, you would get an error. So what I'm doing is that I'm saying that my data from here is just 5. And then I'm now specifying my indices. So I want my indices to start from 100, from 200, from this. So now that I have my indices in here, it means that when I'm trying to access any elements, I don't use the 0 and 1s, but I have to use the indices that I like sort of specified. So let's see some sort of operations we can do with series. So here we can have like series.values. This gives us like the data that we have in here. We can have like series.index, which returns just the indices. We can have like this sort of index. And so like I said, if you like sort of index with just 1, you get this first one because this was the indices. So if you are trying to find this one here, we have to like index with 0, like 200 or like 100. So let me try to do that here. Oh, I didn't name this one. Series 2. So let's see what happens when I put series 2 and index it with 1. I'm sure it's going to be like an error. Exactly. This is because like we don't have indexes like, no, I have to print that again, series 2. So here we don't have indexes 1, 2, and 3, but like rather 100 and 200. So you have to specify this particular one. So now when we run it, it actually gets 5. So you have to be like very careful of how you index with series. So this is basically just explaining how they provide us with indices. So now if I want to access this particular 0.5, I have to pass this particular index as well. And also the indices are not necessarily very sequential. You don't have to really pass it in a sequence manner. You can just have random numbers, whatever helps you remember what you are trying to work with. So here you can have all of this. So let's see what happens when I try to index with 3, because we have 2 elements that have 3 as indices. So we can see that here it actually returns both of them, because both of them have index 3. So that is what is going to happen. So now let's try to find how we can also different ways of creating series. We can use dictionaries as well. So we can have this particular dictionary. And what we are observing here is that because we have a series from a dictionary, it just takes the keys of the dictionary as our index, and then it takes the values as our actual values. So now let's try to index we did in NumPy array. So we are saying that we want to index from this particular Senegal to Sudan. So we want all the elements from here to here. So here it actually includes the start and then the end, and that is how different it is from Python NumPy arrays. So now that we've seen series, we might also want to look at data frames. So data frames are also just series, but in a 2-dimensional fashion. So here, let's go back to our area dictionary, right? And then we create a Python series from it. So we can either create a data frame from a list, from a dictionary, or from a series. So here we already have our area series, and then we are passing it to a data frame. And the way we do it is with this pd.data frame. We pass in the name of our dictionary, and then we get what we wanted to do. So what we are passing here is we are passing the headers of it. So we have population, and then we want it to have area as well. So this is how a data frame looks like. So now let's try to find area. So when we try to specify it like this, states, and then we have our brackets, and then we have area, then it returns us with all the elements in here, as well as their indices. So this is slightly different from what we saw in series. In series, when we just call this, it just returned it like this. But in data frames, it returns is sort of more specific and more appealing to us. So now we want to have something like this. We want name, we want just population. This is what is going to appear, because we have this. So it's still going to return a data frame and then give us what's the information that we are requesting for. So we can also create it from just dictionaries like this. Then it gives us the column names, then the rows as our indices as well. We can also create it from 2 NumPy arrays. So we still use pd.data frame. Our data is the NumPy array, a 2D NumPy array, and then our indices are this, so A, and then C. So data frames have several operations that we can perform, just any other library objects. We can find the indexes. So the indexes of this particular one, of the states data frame, which is here, is the Senegal, Cameroon, and Mali, and all of that. So this is what is going to return. We can also find the columns with just states.columns, and then it appears like this. So now now that we've seen data frames and how to create them, it's very popular that you find CSV files, and then you have to create your data frame from the CSV file. So let's see how we can do that. So now we had our CSV file. This CSV file is actually in here. So Colab has some sample data that it has over here, all the CSV files. You can just import them and try to manipulate them. So the way we sort of read CSV files into Python is with this pd.read_CSV, which takes in the path of our CSV file. So our path is actually here. You can come and copy it from here. So I want California housing train, right? So I can copy the path of it. And that is what I pasted here. Now, if we sort of run it with df.head, we are just trying to get an idea of like how the data looks like. So we get all of about 5 rows. Then we get all the column names. You see what is like entailing in that column names. So like, let's say we wanted to print about 10 column, like 10 rows instead of like just 5. We can just specify it in here. And that prints about 10 rows in here, right? Then we can also have df.shape, which gives us like the shape of the like CSV file that we have. So this is saying that we have 17,000 rows, and then we have just like 9 columns. So like this is the columns that we are seeing here. So df.shape gives us that. We can also print df.info. So all of this are attributes of the data frame, and df is the name that I assign to my data frame. So which means that anytime I'm trying to call an attribute, I have to use the name that I used here. So this is what the info sort of gives us, like just a general idea of like what is in all of the columns that we have. We can also just print the column names. We can try to find like the maximum of like a particular column. So let's say this column called median value, median house value over here, the last column. We are trying to find like the maximum amounts in there. So like this is actually data of like housing. So like we usually use this sort of data for like predicting house prices and stuff like that. So we are trying to find the maximum of the particular prices. So let's see what that gives us. And that gives us like 50,000. So this means that of all the housing data we have, this is like the highest amount that a house could have been bought for. And this just gives us information like very quickly. So you can also find another one. No, it's actually just the same thing. But it's just like you can either access the column names with this particular one, with just the brackets, or like you just have df dot then the name of the column, and then you have your attributes, and it gives you like just the same thing. So what happens when you are trying to find like several columns? So you can't do it like this. So you can't, if you try to do this, I think you would get like an error, like just pass different ones in there. Let me try to find total bedrooms. You see, this is like an error because this like df and then the column name and brackets just takes one column. So if you are trying to find like multiple columns, we can add 2 parentheses like this, and then we have them in here. And this way, it actually prints what we want. So we can just like, instead of printing the whole data set each time, we can just print like this 2, any 2 or like any ones that we have, and then it puts it in there. So we can add as much as we want, so long as we have like our 2 brackets in the beginning. And it should always be separated with a comma. So this now prints house value, bedrooms, and then the population. So now let's see how we can do slicing and indexing with Pandas data frames as well. So here I'm just printing the households as well. You can do it either way. And now I want to print the first row of my data set, right? This is where I use iLock. Then I pass the row that's I wanted to print. So if I use iLock, it prints like the first row of every column that we have in here. So let's try to pass in, let's say like from 0 to 5, see what happens. So now it prints it like sort of like in a data frame, because like when I printed just the first one, it gives me like just the names and then the first ones. But now that I actually want to print the first 5, it has to like sort of structure is like this. Yeah, and this is basically like the same thing, but from 0 to 15. Now let's see what's happened if you want to index the rows. So this, when you just use like a lock, like iLock sort of gives you like data frames, but when you just use like lock, it just gives you like only like the column names and like the first elements, or like the number of the row elements that you are specifying. And we can also use Boolean indexing in data frames as well. So here, let's say we are trying to find the median house value, like points that are greater than 50,000. So let's see what happens here. So this is all the data you are getting. So let's say like what happened was like we first indexed this is what we want, and then we want it to be greater than 5,000. So out of this, like out of the main data frame, this is just what we want, and we want to assign it to filtered rows. So this is why we are getting this. So this is like a new data frame outside the original data frame that we had. And we can also do like indexing and slicing as well. So let's say here we want to find the median income that is greater than 1.6, and we also want to find the median house value. So when we run this, this is sort of what we get. So I'm using df.log. Then I sort of like index the median income value that I want with this condition, right? Just like we did for this particular one. Then I also wanted to return median house value. So instead of just one parenthesis, I have to put in two. And you always have to make sure that this condition, like it's sort of already referenced from the particular like column that you want, and then you can go from there. So now that you've seen pandas and data frames, like there's actually like quite a lot you can do with that. You can like, let's say replace missing values, you can drop missing values, you can do a lot of things with like pandas. And it's usually like mostly used for like data analytics and stuff like that. But we can also use data frames in like several other like applications as well. And now I don't know how much time we have left, but I'll just quickly like speak through sklearn and stuff. Yeah. So sklearn, just like NumPy and Pandas, is also a library, but this time you can actually use it for like machine learning. Like sklearn gives us like the options to do like a lot of things. So like one funny story, like when I first started my master's in machine intelligence, it was like everything we're doing was from scratch. Like we never used libraries. And like before going there, I knew how to use sklearn and all of this for like very quick data analytics, right? But like they'll tell you to like predict house prices from scratch. You have to write everything from scratch. And it was just like very draining. But afterwards, I sort of understood why we had to do this. Because even though these libraries are there, they have like inbuilt functions that we can use. Sometimes when you like get into an error, you don't really know how to solve that error. But if you actually understand how they work from like the beginning, you can actually like just figure out where the error is, and then you can solve it. And that really helps me to understand like the from scratch, and then to also understand how to use this like libraries as well. So sometimes it's okay to use libraries, but like you might want to have just like a general idea of like what it is doing like under. So sklearn is like this library that we usually use for like machine learning. We can use it for like regression, classification, like anything you can think about. And today I'm not going to go into the details of sklearn, but I'm just trying to use it to like demonstrate like house price prediction, so that you can get like a general idea of like what this particular like library is and what you can use it to do. So sklearn has like several different functions like pandas and libraries. But for now, like with sklearn, you actually have to import some of them that you want to use. You can't just import it like maybe import pandas as PD and then you use all the attributes that are in there. So I'm going to import this particular one called train test plates. I want to import linear regression, and I want to import squared error. So sklearn has like different attributes. So like here, I'm importing the train test plates from model selection. Then I'm importing linear regression from linear model. Let's say if I wanted to do like, let's say a classification or something, I would have to import from that particular model as well. So when you go to this sklearn website, you'd find information about how to use it for like different things. But here I'm just using it for like linear regression. Then I can also go to sklearn.metrics to import the mean squared error. So the metrics is like usually how we try to evaluate our machine learning models, like what is happening with this. And then like to show if like our model is actually doing well and would actually like perform well in the real world. So here I'm using the mean squared error, which is sort of like taking the differences between like what my model is going to predict and then the actual thing that we are supposed to have. So what I'm trying to do here is just like generate synthetic data but I think this is not necessary because we'll be using the housing data frame that we used before. So let me just like print it again to give us an idea of what we are working with. So this is like housing data. So in this housing data, we have like this longitude, the latitude, like all of this, right? And we are trying to predict the house value. So what is happening here is that we already have the sorts of features. So the features are like what informs this house value. So all of this is what is contributing to the house value, right? Maybe the latitude of the house, where it's located, the number of the rooms in the house would inform people on how much people would want to buy it for. So this is what is going to be our features. Then the house value, which we are trying to predict, is what is going to be like our targets, right? So in machine learning, when we are trying to predict something, we should usually have the features and the targets. So the features is like what is influencing, what we are trying to see, like what is influencing this particular thing we are trying to predict. So let's consider like, let's say predicting the weather for instance, what we want to predict is like the temperature of every day. And maybe to predict that, maybe you might want to know the amounts of rainfall, the wind pressure, the humidity and stuff like that. So those are the features. And then the temperature is like the target. So now that I've imported my metrics, I'm trying to like show that this is the particular ones that I'm trying to predict. So I have to specify which ones are my features and which ones are my targets, right? So this X represents my features. And my features, I'm selecting from the data frame, all of this. So all the columns that we have aside the median house value. So because the targets cannot be part of the features. So that is what I selected here. Then I also have the median house value as my target. So that is my target variable. So now I want to split my data into training and testing sets, because if I don't do that, it means that I'll train the model with all of the data, and the model has already seen all of the data. So like what is going to like actually like give out as predictions might just be memorizing. It might not have actually learned like the patterns in the data, but it's just trying to like reproduce what I fed into the model. So this is why I have to like split my data into like training and testing sets, train with the train sets, and then try to predict with the test sets. So I'm dividing both my features data and then my target data. So I'm now dividing this into X train, X test, using this train test splits from sklearn, right? So I split all of the data with like a 20% ratio. So this means that I'm reserving like 20% of my data for sort of like training, and then I'm using 8% for like sort of like testing, training the data sets, and 20% for testing. So now I'm going to create my model with linear regression, and the way we do it in sklearn is just like the name of the model followed by a parenthesis. And now I'm trying to train my model on the training data. So the training data now has like the X train and then the Y train, because I've told my model that this particular features is what is causing this particular like amounts of like house prices, right? So this is where I passed my X train and then my Y train to train the data. And now I try to make predictions. So the predictions is now done with the data that the model hasn't seen before. So my predictions, which I've stored in YPred, is just predicting the X training data, the features. So it takes in this particular features that it hasn't seen, and then it gives me this one. So the predictions it gives me is the house values that is given for this particular one. Then I will now try to calculate the error. So the error is simply like trying to find the difference between what the model has predicted and then what is actually the real value. So let's say we had like a house price of like 50,000, right? And my model predicts like 52,000. So this means that the difference between the model is like 2,000. And that is like the amount of error that the model is giving me. So that is what the mean square error does. There's a whole mathematical function behind this, which we are not going to look at. So now I want to print the coefficients and the intercepts. So basically what a linear regression model does is that like it sort of have like a dependence variable and an independence variable with coefficients. And this sort of informs us as to like how far the model has like used the attributes that we gave it, like the features we gave it to like predict a particular one. The relationship between the features and then the targets that we had, which is the dependence variable and the independence variable. So when we print this, we can just see the coefficients of the model, which you can use to like write our linear regression equation. So now we can see that my mean squared error is like this huge amount, which is like, if we're using real data, this should really be like a big deal because our model is not like doing well. The error is like a lot, but this is just like data for demonstration, so it doesn't really matter. And this is our coefficients of the linear regression model. So because we passed in so many features, all of these are coefficients of every feature that we have. So if we're writing the equation, we might have something like y is equal to ax plus bx and stuff like that. And this particular values are the coefficients that would be attaching to like our variables. So now that we've done like a simple house prediction with sklearn, let's see what is happening. Let's see the prices that our model is predicting. So you see that this is the values our model is predicting: 143,000, like 39,000. And let's look at the actual house values we had here. They were like 66 and like 5 figures, but our model is predicting like about 6 figures. This shows that the error in the model is like very high. And like I said again, this is just data for demonstration, so it doesn't really matter. So now let's just try to like plot it and see like an idea of what is happening. So when we plot this now, we see that this is the actual points, right? This is the ideal points that we have. We want all of these points, our predicted points, to be on this line, but they are actually like very far away from the line, and that is how the error is being measured. So basically, this is what our model is doing, but what it should have done is try to fit like all of these points in some way. So maybe we either have to choose like a model that has a higher capacity, or like we have to like reduce the number of features we are using here. We have to select the ones that are actually contributing to the house prices rather than just like using all of them. And that is what is known as feature engineering. And like, you don't really have to know all of this. This is like machine learning, which I think you guys would do later. But this is just to demonstrate how sklearn works. And yeah, I think I finally come to the end of it. But before I go, I would just like to mention that we need to fill this feedback form of the organizers. Like, this is really important to them, and this is why I kept it in capital letters. So I'm not shouting, but I'm just stressing on like the importance of it. And I also left like a few exercises here for people that want to like try their hands on it. I'll try to solve these exercises and then put the solved code in the Discord as well for people that want to actually get into it and understand. And I'm on Discord as well. So if you didn't understand any part of this tutorial, please feel free to like reach out and I can actually explain to you one-on-one again. So yeah, this is some resources you can look at and like what I use for like my work and stuff like that. So feel free to reach out, and if there's any questions and there's still time to answer them, I'm happy to take them.
Thank you, Khadija, for for the very interesting session, for taking out your time to share knowledge with all of us here, scholars and organizers alike. So if you have any questions, maybe ask a question that was not answered, or you have a new question, please just raise your hand or drop it in the comment section so that our instructor can attend to you. So any questions? Also, as we accept questions, please fill the feedback form. It's important both to us and the instructor. So please fill the feedback form. The link is in the chat. Okay, there's a question. Okay, this question was asked earlier. How do you know that data is two-dimensional? That's the core of the question.
Okay. Yeah, so you can know that the data is two-dimensional if it's not just a vector. So one-dimensional data is typically data that is just like maybe one vector, like maybe an array of like just the names of the people here. But like if you want to extend it to like having like 2 of the vectors, that is when we have like 2-dimensional data. So it's sort of like 2D has like multiples of vectors in them. 3D has multiples of 2D, and then 4D has like multiples of 3D in them. So that is how you can tell like the dimensions of the data.
Okay, thank you. Also, a question was asked earlier on whether we can do Boolean checks with categorical data. So,
yes, I think you can do it with categorical data. It's like if it's strings, you just have to specify your conditions to be strings and take note of like the capitalization and everything. And you should be able to like pick out the conditions that you want from the data and return the format you are asking for.
okay. Someone just asked not too long ago, what other aspects of data can one analyze aside CSV? So other kinds of data.
Yeah, so we also have data in Excel. You can also like import pandas with Excel data. You can also, we have other types of data like let's say I work in like medical imaging and stuff like that. So sometimes you have like JSON files, sometimes you have like events camera files. Like you don't really have to know the formats of this data. But like as you move on, you start encountering new types of data and you can always like import them with pandas.
All right, thank you. Someone also asked, is there data sets from Excel?
I don't really understand. Do you mean in Colab or like in just Excel, like Microsoft Excel?
Perhaps I'm guessing they want to know if you can get some data sets or maybe data sets in Excel format.
Yeah, you can. Like I mentioned before, you can use pandas to import like Excel data sets.
Okay, and okay. How can we create our own CSV data? Do we enter it one by one, or is there a way to automate it?
Yeah, so there's a lot of ways of doing it. You can enter it one by one, which is time consuming, but you can also use just NumPy, like the way we mentioned before. Like, let's say you want to have a data frame of like maybe 2 columns of like people's names, like initialize it with random numbers. You can always just use like the NumPy functions like np.1s, np.0, stuff like that to create your NumPy arrays, and then you can convert it into like a data frame, which you can then save in a CSV file. So I think in the tutorial, the data that we created and then saved in our CSV file is in this data.csv, which you can download to your local computer, and then you can always use it for anything you want to do.
Thank you. Any other questions? We still have 3 minutes. Sure. Just don't have a question. Can you briefly highlight on how to encode categorical data?
Oh, this is actually a very good question. It's actually been a while I've worked with like very numerical data, but there's several ways of encoding categorical data. What you can do sometimes is just with conditions. Like let's say you have data of like, let's say for instance, this particular median house value wasn't like in numbers, but like they were in like strings of like maybe yes or no or something like that. You can just use a condition to say that it should go into this data frame. If it finds anything which is called yes, like as a string, then it should assign 0 to it and it just becomes numbers. Or otherwise it should assign 1. And that is like one way. But I also know about, I think, bytes per encoding or something. I'm not really sure about this. Like it's been a while I revisited this, but you can look at that as well. Maybe for like NLP data sets or stuff like that.
Okay. Thank you. Someone asked, is Scikit the same as SQL?
Yes, it's the same thing, if I'm not mistaken. It's actually the same.
Okay. So I think Samuel Ikuma has a question. I'm trying to get him some minutes. Where is he? Okay, Samuel Ikuma. You can unmute yourself.
Yeah. Good morning, Ma. Good morning, host.
Good morning.
Okay, please. This is actually related to today's topic. I've been battling with organizing my data sets. I have this data set. It's actually in an Excel form. Some of the data are in text, while some some are in Word document, while some are in PDF files, while some are in Excel. You understand? I want to now I want to extract those data and have them in a CSV format so that I'll be able to work with them. So I don't know how to actually do it. So since some other person has actually brought it up, I said, let me ask to know if there's how anyone here can actually assist me, guide me on how to do it, because I really need to fix it to work, please.
Okay, so I think with the Excel, there's a lot of like online, just like go on like Google, like change Excel to CSV. There's a lot of files that you can use to do it. You can also just open Excel. I don't know about maybe Excel for Windows, but like some Excel files like on Mac, you can just go into like the Excel app and then export it as CSV directly. Or you can also upload it to like Google Sheets, and then you just download it as a CSV file. So it automatically like converts it for you. But for the data with the PDF, there was a time when I sort of like had to move data from PDF files into like a CSV file. And it was done with a certain program. I don't really remember the name of the program, but I can check that and get back to you. So it's basically like if you have like tables in PDF files, you can use that program to sort of just scrape the particular data you want into your CSV or like into your Excel, and then you can organize and remove the particular ones you want, and then use the rest of the data. And I'm sure there's a lot of online resources that can do that as well. So you might want to check like those options.
Okay, thank you. I was also going to mention for getting data from PDFs. There's this app, it's called Sensible. I'll drop the link in the chat.
Okay, please do it for me.
You can use it to script, because I don't know about Word documents. Maybe if you convert the Word document to PDF, you can also use the app to script.
Okay, I convert the Word documents to PDF, then use the app and get the data into a CSV format. Is that right?
Yeah. So I'll drop the link now. You can check it out. Interesting app. Okay. Someone also asked, will you advise Jupyter notebooks or Colab?
Okay, so it actually depends on like what you are doing, like the task you are trying to solve. So for basic stuff like house prediction and stuff, you can always use Colab Notes because your code is online. You can always access it from any computer, like anywhere. Whereas with Jupyter Notebook, it saves it to your local machine. So sometimes when you're away from that machine, you can use it again. But one other thing is that Colab has like GPU restrictions and like usages. So when you're working with very large data, you might not really be able to use it the way that you want to, because there will be times when they would have to like stop you, like your GPU is like up, you have to like subscribe like monthly and pay and then use it. So that's where you might want to use Jupyter Notebooks. And also with Colab, sometimes I think you can't import folders, right? So like maybe if you have data like in folders that you want to access for like maybe efficient tasks, you have to like upload it into your Google Drive, which is just like taking more space on Google and stuff like that. So you might want to use just like your local machine for maybe very large amounts of data, and also like types of maybe machine learning works that really requires a lot of GPU that your local computer has that Colab doesn't have. So it really depends on the task that you are trying to do.
All right, thank you. And someone just asked, maybe this might be the last question since we're past time. How does one keep track of all the libraries existing in Python and know when to use each?
Yeah, so it's really overwhelming when you're trying to just keep track of it in your head. Like I can relate to this. Sometimes you are doing something and like you are so stressed out by the code that you don't even know that np.once can do what you are trying to do, and you're like just typing one sentence because you are trying to like have everything in your head, like know all the sorts of tags that you can do with sklearn, know all the machine learning tools. It's really like very overwhelming. So what I would advise is that know the field you are interested in, is computer vision or NLP, know the particular ones that you have to use. So like you can join coding challenges, you can like just practice on Kaggle, you can practice on LeetCode. Like when you have those frequent code interactions, you like unintentionally gets to use some of this without even knowing that you do. So like maybe you get stuck in a problem, you go on Stack Overflow, you see that they actually use this sort of problem, this sort of library to solve it or something. Or maybe just on LeetCode, like after like solving the tags that you have, you can go to the discuss section, see how other people solve this. And that is really how you get to know like all these libraries. But if you want to just go to their websites and learn what they all do and like just have it in your head, like trust me, it's not really going to work at all. So just try to practice more, and that's where you get to use like more of them. And then you get like once you use something, it sort of like sticks in your head. So like you just get to know it that way.
All right, thank you very much. I think if we have any other questions, I'll encourage us to drop them on Discord. Khadija is on Discord also, so you can just tag her. I'm sure she will give you a good response. Okay. Also one more question. Let's take this one. How can you please can you briefly highlight on how to encode categorical data? I think this one has been answered.
Okay.
Right, Khadija? Yeah. Okay. So thank you. And also thanks everyone for staying on the call for over 2 hours. And yeah, the notebook I've already been shared with you. So if you need to go back and go through it, please do. Any questions you have, make sure to ask on the channel on Discord. And I wish everyone a wonderful weekend. Thank you for attending. Also, feedback forms, attendance forms. If you've not filled them, please do.
Okay.
Thank you very much.
Bye.